Okay, just a few reminders. Today we're going to turn in 12-1. Then I will finish lesson 12-2. I didn't quite finish it last time, so I'll finish teaching you that one. And I'm also going to teach you 12-3 because 12-3 is one formula, and we're going to do a little activity to learn about it, a little paper folding and tearing activity to learn about it. And then we are going to also give you a 12-3 assignment. Will only be a few problems. And those will both be due. 12-2 and 3 will be due next time, as well as we will take the test next time on that, okay? And I will also assign you guys your groups for your presentations that you will be doing on Tuesday next week. Okay, so we'll be doing that, okay? So on Wednesday. So that's where we sit with that. Okay, find the 200th term of the sequence below, then the sum of the first 200 terms of the sequence. So who wasn't here besides Maddie last time? This sums up what we learned in 12-1 right here, okay? We learned how to find, we have a formula for finding the 200th term, for finding the nth term of an arithmetic sequence. Let's check to see if this is an arithmetic sequence, is it? What's the difference between terms? 6, 6, 6, and 6, right? So an arithmetic sequence is a sequence that with a common difference between terms. Okay, so we have that. Now, we have a formula for finding the nth term. Okay, it is a sub 1 plus n minus 1 times d. A sub n stands for the number of term we want. So we want to find the 200th term. A sub 1 stands for the first term in the sequence, which is 8. N stands for the number of terms, 200. So 200 minus 1 is 199. And D stands for the common difference between terms, which is 6. So we plug those into our nth term formula. Everybody can understand that that's called an nth term formula for an arithmetic sequence. N stands for the number of terms we're looking for. The 200th term, 200 minus 1. We want to find the 200th term. A sub n stands for whatever the 200th term is, which we're going to find out right now. So all we do is we put this into our calculator. 8 plus 199 times 6. What do you guys get? 1202? Okay, 1202. So 1202. So the 200th term is 1202. Okay, if we were to continue this pattern out for 200 terms, that's what we would get. Okay? Now, we also had to find the sum of the first 200 terms. We learned two formulas for the sum. We learned the formula that was n divided by 2 times a sub 1 plus a sub n, right? That quantity. And in order to do this, you had to know the first and the last term. Okay? Well, we happen, since we just figured out what the last term is, we found that one out. But if I hadn't figured it out, first of all, here's another formula. If I would have substituted this formula right here in for a sub n, because that's what this is, a sub n, right? Then I would get a sub 1 plus a sub 1, which is 2 a sub 1s, plus n minus 1 times d. Okay? So there's the second sum formula, and that's in case you don't know what the last term is. Now, since we just went ahead and found out the last term, we can use this first formula that we wrote down for finding the sum. Yes? A sub 7 is just like this. Find the seventh, it means to find the 7th term. Is this on 12-2 or 12-1? So they're giving you the last term. They're giving you D, right? And what is it asking you to find? Yeah, it wants to know the first term. So what you're going to do is you're going to substitute everything into this formula. You know the last term. You're going to substitute that in. You don't know A sub 1, but you know N and you know D. So you substitute those all in and you solve for A sub 1. Does that make sense? Okay. So we're going to finish this problem off. S sub 200 is equal to N divided by 2. Well, 200 divided by 2 is 100 times the first term, which is 8, plus the last term, which is 1,202. Okay, and we get what? 121,000. Yeah, I was just about ready to say that. 121,000. So if you add all the terms, if you went 8 plus 14 plus 20 plus 26 plus 32, clear up to the 200th term, you'd get 121,000. Any questions on this problem? Okay, that was kind of a summary of what you learned in 12-1, in case you missed it. No, you have, it depends, you have a sum formula for both an arithmetic sequence like this and geometric sequences. I haven't taught you that formula yet, though. We're going to learn it right now. Do you guys understand the difference between arithmetic and a geometric sequence? I will. Okay, let's do those right now. Let's just do a couple of them. Which one? Huh? 44? What does 44 say? -5 what? Continue. Find what again? The sum of the first terms. Okay. This wants me to find S sub 100, you guys. Do you understand how the question is being asked? It said find the sum of the first 100 terms. It wants me to find S sub 100, right? The sum of the first 100 terms. It gives me this sequence right here. Well, we just learned a formula for it. We learned 2 formulas for it, right? The question is do we know the 100th term? No. So we're going to probably want to use the second formula. We don't know the 100th term. So we're going to probably want to use the one that goes 2A sub 1 plus N minus 1 times D. That's the formula we're going to want to use. So let's see what we know. Do we know A sub 1? So let's plug it in. 2 times -5 plus, do I know N? It's 100. So 100 minus 1 is 99 times the common difference. Do I know the common difference? Not 0.2, -0.2. Oh, it is positive. You guys are right. Sorry, my bad. I just saw negative numbers up there and I assumed. Okay. It's going up, isn't it? -5 to -4.8. You had to add a positive number to get that. Okay. So all I have to do is stick that in my calculator and get my answer, guys. Oh, yeah. N divided by 2. I forgot that part. N divided by 2. Okay. So we forgot that part. We'll write that down here. So 100 divided by 2, right? Which is 50. Okay. Plug that in your calculator. What do you get? 490? Everybody agree with that? S sub 100 equals 490. Okay. You guys know we would have went 0.2 times 99 first. And 2 times -5 is -10. Plus whatever 0.2 times 99 is. 1.98, is that what? No, 19.8. 19.8. Negative 10 is going to make 9.8 times 50. 9.8 times 50 is, go 9.8 times 50 for me. 490. Okay. Just wanted to make sure you guys did order of operation right. Okay. What's that dot? It means times.
I know that, but you.
Huh? I didn't need both. You're right.
So I was wondering if it was like something.
No, it's just that I wrote that before I realized I was going to be using 99 times 0.2 if you want to look at it that way. Okay. Sydney. 32. What does 32 say? And it wants to know a sub 1. Okay, so it wants us to find a sub 1. Do we know n? What's n, you guys? 7. How do we know that? Because it says a sub 7 right there. Find the 7th term. That's the 7th term, right? So, and it wants us to find a sub 1. So we can take this a sub n formula equals a sub 1 plus n minus 1 times d. And we're just going to plug in what we know. Do I know a sub 7? A sub 7 is 10 and 2/3, right? I know the 7th term. Do I know the first term? I do not. I'm just going to call that A. Do I know N? 7. Minus 1 is 6. Do I know D? 1/3. So I plug everything in. The only thing I don't know is, yeah. Now you understand? Okay. What's 6 times 1/3, you guys? 2. And by the way, remember how to change a mixed number to an improper fraction? Three times 10 is 30 plus 2 is 32/3 plus, equals a plus 2, right? Minus 2 from that. We probably could have just left it at that. 8 2/3, sorry. I thought we were going to be multiplying, but I forgot. 8 2/3. How many of you got that for the answer on that one? Okay. That's basically what we're doing on those problems right there. Okay, we're going to do number 40. What does this one say, Mikkel? Between -5 and what? With 2 arithmetic means? Between -5 and what? 4. That's all it says, right? It says find what? Okay, write a sequence that has 2 arithmetic means between -5 and 4. Okay. This one we could actually probably kind of do in our head. I mean, I'm pretty sure it's going to be this. You can do that one in your head. No. Look, what's the difference between terms here? Okay. Well, I taught you a problem like this. But let me show you how to do it the other way, because it's not always as easy this way. All I did is, what's the difference between -5 and 4? How many units from -5 to +4? 9 units, right? And I know I've got to go 3 spaces, even though there's 2 numbers in between here. I mean, to get from this one to this one, that's a space. From this one to that one, that's a space. From this one to that one, that's a space. So I took 9 and divided it by 3. What's 9 divided by 3? 3. So I just knew my common difference was 3. So negative 5 plus 3 is negative 2. Negative 2 plus 3 is 1. 1 plus 3 is 4. That's what I did, okay? But I taught you this way right here because sometimes it's a lot more difficult than that. So I taught you guys to use this formula, a sub n equals a sub 1 plus n minus 1 times d. And we're going to plug in what we know. A sub n, we got 4 terms here. 1, 2, 3, 4, right? 4 is the 4th term. So we know that a sub n is 4. A sub 1 is the first term, which is going to be negative 5. N is 4, so 4 minus 1 is 3 because we have 4 terms there, right? And d is what we don't know, and so we're going to solve for that, okay? So I add 5 to both sides, and I get 9 equals 3d. Divide by 3, and I get d equals 3. There's my common difference. I just say, okay, negative 5 plus 3 is negative 2. Negative 2 plus 3 is 1. And 1 plus 3 is 4. I've got it. Okay? So essentially, I did that in my head, but just not using that formula. So that's how you're going to do it on the test, probably, because it's going to be a lot more difficult problem than that, most likely. But it doesn't necessarily. And just plug it into that formula and solve for D. Okay? Got it? Okay, Maddie. Okay, this is the last one for sure, guys. Here we go. 52. What does it say? Is that the one with the triangular, the bricks? Read it to me, Sadie. What does it say? Oh, who's got their book open right here? Wants to read number 52. Okay, go ahead. Okay, so they're going to stack these bricks. How many bricks on the top? Did it stay with the starts with the top row, right, or the bottom row? 5 bricks. So is a sub 1 equal to 5? Is that how many is in my first number? There's 5 bricks in the first sequence, and don't they have, how many do they add each time? How many? Are they adding 4 or 2? Some of you guys are saying 4, some of you 2. Okay, so 4 blocks, is that what you're doing? So what does that represent? The difference, the common difference, right? Is 4. What is n? How many? Yeah, 25 is how many rows there are in this case. So there's 25 rows, is that what you said? That's all I need, isn't it? They want to know how many bricks you're going to need, right? Which formula am I going to use? The sum formula, right? S sub n. S sub n equals n divided by 2 times 2 a sub 1 plus n minus 1 times d, right? So S sub 25, the sum of the first 25 terms of this sequence, or rows of bricks in this case. So 25 divided by 2 is 12.5. 2 times a sub 1 is 10, because as a sub 1 is 5, 2 times 5 is 10. Plus n minus 1 is 24, because n is 25, minus 1 is 24, times the common difference, which is 4. And I just plug that into my calculator. What did you guys come up with? 1,300 and what? Wow, can't even write a number. 1,325 bricks is how many they're going to need to make their patio, right? Got that? Okay, so that's how you do those. Okay, we're going to finish lesson 12-3. We started on it the other day. I can't remember. Did we do this problem the other day in class? I think we did, didn't we? We did it, right? Yeah, find the approximation for the 23rd term in the sequence. Let's just do this problem just to kind of review what we were doing. Okay, you guys, we're talking about now a geometric sequence instead of an arithmetic sequence. We are talking about geometric sequences. How do geometric sequences differ from an arithmetic sequences? They have a common ratio, right, instead of a common difference between terms. In other words, they've got a number that we're going to multiply by the previous number to get the next one. In this case right here, I got to multiply 256 by some number to get negative 179.2. And then I've got to times this negative 179.2 by a certain number, that same number, to get 125.44. So the question is what is that number and how do we find it? Yeah, this is 12-2 notes. I divide a term, I divide a term by its previous term, right? Okay, so what's negative 179.2 divided by 256? Negative 0.7. So that right there is what is known as my common ratio. Did you guys say negative 0.7? So my ratio is negative 0.7. Okay, now we learned a formula for finding the nth term of a geometric sequence. It was a sub n equals what? A sub 1 times r to the n minus 1 power, right? So what else do we need in order to do this problem? We need to know what n is. What is n? It tells us in the problem. 23. We need to know what else. We have r. We need to know a sub 1. What is a sub 1? 256. Remember, a sub 1 always stands for the first term in a sequence, right? So I have enough information to find everything out, right? So I want a sub 23 equals a sub 1, which is 256, times the common ratio, which is negative 0.7, raised to the n minus 1 power, which would be 22. Now, when we did this in our calculators the other day, we found out that it gave us a number in scientific notation, right? So I want everybody to put this in your calculator because I want you guys to all see what this looks like in your calculator, and then we'll change it right here. What does it look like in your calculator? Sadie, will you read it to me? What is it? Oh, you guys didn't get scientific notation? Let me see what you got. Oh, yeah. Well, give me the answer. What? Oh, when you finish it out, it's not? It should be. Oh. Well, you guys, let's just type it in all at once. 250. Go. Everybody type it in. 256. And then put the parenthesis, negative 1.7, the ending parenthesis, and then hit the caret key, 22, hit enter. Negative 0.7. And what did you get? 0.1110. And then it said E. It doesn't say E? Really? Oh, I was thinking of a different problem. Well, there's your answer. Okay, no scientific notation. It's a small number, right? Think about it. It is getting smaller every time. It's alternating back and forth, negative, positive, because the ratio is negative, right? Okay, so A sub n is this number right here. In other words, the 23rd term is 0.10009141188. Okay, A sub n stands for the number of term we're looking for, the 23rd term. This one right here? Yeah, this is the, guys, this formula right here that I circle in green is called the nth term formula for geometric sequences. This is how you find, if I ask for the 23rd term like I did in this one, of this geometric sequence, that's the formula I'm going to use. Is that what your question is, Easton? Okay. Okay, next slide, right here. Geometric means. We just did a problem where we had arithmetic means, right? Okay, so we're going to do this one right here. The terms between any two non-consecutive terms of a geometric sequence. Write a sequence that has two geometric means between 48 and negative 750. Okay, I want you to write these four terms out. Of course, put blanks where the two terms are that you don't know what they are. What would that look like? So what are my two non-consecutive terms right here? What are my two non-consecutive terms? Are you guys all still writing? I'm going to pause this for a sec. Okay, so if I was to write this out, there's how many terms in my sequence right here? 4 terms. What's my first term, everybody? 48. What's my second term? We don't know. Blank. What's my third term? We don't know. Blank. What's my fourth term? Negative 750. Now, the first term is positive. What do you think my second term is? Negative. My third term? Positive. And my fourth term? Negative. And we can tell that because we can see what the last term was, right? So it's going to be positive, negative. So I know that my geometric term is going to be, my common ratio is going to be a negative number. Okay, I've got to solve this. I can just use that formula we just learned. A sub 1, or A sub n, sorry, equals A sub 1 times r to the n minus 1. I can plug in what I know. Do I know A sub n? What is A sub n? Negative 750. It's the last term, right? Do I know A sub 1? 48. Do I know r? No. Do I know n? What is it? 4 minus 1 is 3. Okay? So, I need, well, how many terms do I have in my sequence here? N stands for the number of terms there are in a sequence. So, got it? So I can just solve that for r. What am I going to do to solve that for r, you guys? Okay, divide by 48. What is negative 750 divided by 48? Negative what? Does everybody agree with that? How do I get r by itself? Cube root. You guys all know how to do that on your calculator? .625. Yeah, you guys, we got to carry this out. 25. Negative 15.625. Take the cube root of negative 15.625. Well, there's two ways you can do it. There's a hit your math button and there's a cube root button on there, or there's an X root button. If you have to do higher than a third root, you can put in, like if you had to do a fifth root, you'd hit 5, then you go to your math button, hit the X root button, and that would be a fifth root. So what do you guys get? -2, -2.5, -5/2. Okay. So now that I have the common ratio, can I find, let's go back up here. You don't put 3 square root, do 3x root. You can do that, or you can just hit the cube root. Under math, there's a cube root button. Okay, what am I going to do to get my second term, guys? Okay, 48 times -2.5, what is it? -120 times -2.5 times -120 is what? 300, positive 300, huh? And then times that by -2.5 and see if you get -750. Yeah, you do. Okay, so that's it. You guys think you can find geometric means? Okay? Okay, here's the next slide. A geometric series. Okay, what is a series? A series is just a geometric sequence in which you find the sum of the terms. So the indicated sum of the terms of a geometric sequence. I'm going to pause it for a second. Okay, so example, what is the sum of the first 5 terms of this sequence? Now, you guys, there's 2 ways we can do this. The first way is to list the next 2 terms and just add them together. Wouldn't that be easy to do? Okay, everybody do this one. Find the sum of the first 5 terms of this sequence. I'm going to give you a minute. Go. Okay, so you guys got 363. So what's the ratio right here, you guys? 3. 3 times 3 is 9. 3 times 9 is 27. 3 times 27 is 81. 3 times 81 is 243, right? Just add these up. So we find 3 plus 9 plus 27 plus 81 plus 243, and you should have gotten 363. Is that right? Okay. That's one way you can do it. If it's not very long, if it's not very many terms, you can just do it like that, right? Okay. How about that one? Find the first 5 terms of this sequence. The answer is a mixed number. The answer is a mixed number. Write the answer is a mixed number. What is it? 5 terms. Find the sum of the first 5 terms of the sequence. What? Close. That's what I got. 21 and 5/16. Okay. So, what's the next 2 terms, you guys? What's the next 2 terms? 1/4 and 1/16. Because the common ratio is what, you guys? 1/4. The common ratio is 1/4, right? Times the previous term by 1/4 to get the next term. Okay, so I have to find 16 plus 4 plus 1 plus 1/4 plus 1/16, right? Well, the first 3 are easy. They add up to 21, right? The last 2, I probably want to get a common denominator. What's the common denominator of the last 2? 16. And that one, the second one, the denominator didn't change. The first one, what's the top part? 4, because 4/16 is 1/4. 4/16 plus 1/16 is 5/16. So my answer is 21 and 5/16. Any questions there? Okay. Now, This is a formula in case you get a lot larger sequence. Formula for the sum of a finite geometric sequence. By the way, you guys, sums on geometric sequences, they can get really huge really fast, or they can get really small really fast. A geometric series is finding the sum of a sequence. We just call it a series when we're finding the sum. So a formula for the sum of a finite geometric sequence or series, you could write even. So this is finding, if you have a geometric sequence and you want to find the sum of so many terms. Notice it says the word finite. What do I mean by that? There's not an infinite number of terms. It ends. I've got to have a definite number I stop on, right? Does that make sense? Okay, so because in just a little bit, 12-3, we're going to learn about adding infinite geometric sequences. Okay, so find the sum of the first 10 terms of the sequence. Okay. Find the sum. Using this formula, I want you guys to find the answer right here. Negative 236,000 what? You guys both are close to the same thing. You guys clear up there. Let's see what you did. Okay. S sub what, you guys? 10. I'm finding the sum of the first 10 terms is what that means. Equals A sub 1. What's A sub 1? 16. It's the first term, right? Minus A sub 1 times R. What's R? Negative 3. To the what power? 10th power. All divided by 1 minus what? 1 minus negative 3, which is 1 plus 3, which is 4, right? Okay, so you know what? When I do this one, I would just type it in my calculator. 16 minus 16 times negative 3 raised to the 10th power, all divided by 4. Did you do that? And what did you get again? Negative 236,000 what? 192? How many of you had that as your answer? Let me see your calculator, see how you put it in. Make sure we got it right. Oh, you did it all separately, didn't you? Okay. Okay, you guys, we can go 16 minus 16, parenthesis, negative 3, raised to the 10th power, all divided by, you know what? I'm going to put parentheses in just to make sure. All divided by 4. Negative 236,192. That's the correct answer. Okay. Okay, here is lesson 12-2. I gave it to you last time. So if you didn't get it written down, there it is. Hey, you guys, I want you to tell me, is it possible to add up an infinite number of terms and get a finite number? Ramon says yes. And Sean said, what, are you just going along with Ramon? Hey, you guys, okay, try it on this one right here. What if we said this one right here? I said add up an infinite number of terms of that sequence, are you going to get a finite number? Everybody got your calculator and go 5 plus 50 plus 45 plus 135 plus whatever the next one is plus the next one plus the next one. What's happening to this one? So what's the answer to my question? The answer to this one is no. But the answer to my question when I said, is it possible to add up an infinite number of terms of a geometric sequence and have it be a finite number? The answer to that is it is possible. But what's the common ratio of this one right here? What's my common ratio? 3. What do you think my common ratio would have to be to make this work? Less than 1, like -5? And greater than 0. So a number between 0 and 1, you're saying. All right, let's try one out. Okay? Let's say I have, let's go with 32 as my first term. Then 16. Then 8. Then 4. Okay. What's going to happen here, you guys? It's going to, what's happening to my number each time? Andrew said it. What'd you say, Andrew? Please don't. It's going to get closer and closer to 0, but it's never going to get there, right? But that number is going to get really small, isn't it, after a while? Let's list out a few more terms. What's the next term? 2, then what? 1, then what? 1/2, then what? 1/4, then what? 1/8, then what? 1/16, then what? Then what? It's going to keep getting smaller and smaller, right? Then 1 over 128, 1 over 256. That number's getting pretty small, isn't it? Pretty small, okay? And if I keep going out there, pretty soon that number's going to be so small, it's going to be like adding what? Almost nothing every time, right? Okay. Ramon showed me something that was really cool a couple days ago. And I'm going to ask Ramon to come up here and show us what you found out. Will you show us that proof that you did, Ramon? Ramon, I had never seen. Where did you find this, Ramon? Did you just make it up yourself? Have you seen this before? Uh-huh. Okay. Enterprise. Yep. Okay, show us. Ramon's going to show us what he's doing. I'll talk so the people on the thing.
Let's say x is equal to 1/2 plus 1/4 plus 1/8, and that.
What's his common ratio, you guys?
That's 4.
And it's 1/2, right? His common ratio is 1/2. Okay. Hey, you two, stop.
Let's say
and
this
listen.
keeps forever. So yeah. So you just
He's going to do a proof that shows that you're going to add an infinite number of terms. So, do you guys see what he did? What did he do? He times both sides by 2. When he times 1/2 by 2, what does it become? 1. And 1/4 becomes 1/2. 1/2, right? 1/8 becomes 1/4. Okay, go ahead, Ramon.
So this over here is just x. So 2x is equal to 1 plus x.
Okay, let's stop right there and talk about that. Okay, so what he did right now is he's just saying, see this right here? 1/2 plus forever. Well, isn't that what this is right here? Okay, and it's equal to x, so he was able to replace this with x. That's what he's saying he's doing. Does that make sense? Okay?
So just minus x to both sides, and x is equal to 1.
In other words, he just proved that the sum of that series right there is 1. Well,
This is just x.
he's showing that, see this 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, so on forever? Isn't that what this is going to be? Because when you times both sides by 2, it just shifted down the numbers. It put a 1 plus all that, right? So all this stuff right here is equal to all this right here, which is equal to x. So you can replace that with x. So all he did is he put 1 plus x right here. And then subtracted x from both sides. He got x equals 1. He just proved that right there. All right, Sean. It does. It becomes 1. He just proved it right there. No, he just times both. Whatever you do to one side of the equation, you can do to the other, right? He times both sides by 2. He times the left side by 2. He times the right side by 2. That's it. Assuming that x equals 1? No. That's assuming that x equals 1? No, it's not assuming that. What are you saying? We're going to take this piece of paper. And we're going to do this sequence right here. We took a third of a piece of paper, okay? We take a third of a piece of paper, and I'm going to show you guys that this sequence adds up to, I believe it's 1/2, if I remember right. Okay? And I am going to take now and divide this. I'm going to fold this one into thirds. So throw this one into thirds now. What's my common ratio now? Okay, so I'm going to fold this one into third. And I'm going to tear this piece of paper once I get into thirds. Okay, so I'm going to put 1/3 in this stack and 1/3 in my other stack and keep the other one in my hand. Okay, so how much of the whole piece of paper is this thing, you guys, right here? This is 1/9, so I have plus 1/9. This is not going to make sense for the people watching at home. But okay, now I want you to know I have two stacks. I have a 1/3 plus a 1/9 in this one, and a 1/3 plus a 1/9 in this one, right? And I wrote 1/3 plus 1/9 up on the board. Do we understand that? Now I'm going to take this one and divide it into thirds. So fold it into thirds one more time. And tear this one into thirds. 1/3 there. And 1/3 over here. We gotta hurry. We don't have much time left. Okay, so how much of this piece of paper is this one, you guys? 1/27. We're gonna do it again. Divide it into thirds. Oh, whoops. I'm gonna have to keep the good piece right here. Okay. Okay. I've done this before where I get, okay, here's, so I'm going to put one of these here, one of these here in that pile. So how much do I have in each one of those piles? What's my next piece? 1/81st. So this size is 1/81st of my paper, right? Fold it into thirds. You get the idea here? I've had some kids get this down to like really small pieces. They'll tear this down until it's no more. Okay, so I'm going to put one piece in here. One piece over here. How much is that, you guys? How much is one of these pieces? 1/243 of the paper, right? Then I can fold this one into thirds. Now, you guys, I want you to see that after a while, I get it down where there's 1/3 in that pile. I mean, how much of the piece of paper is in this pile and how much of the piece of paper is in that pile? All but this point right here. How much about, approximately? 1/2, right? Here, I'm going to give you guys your assignment. It's really easy. Never mind. I'll give it to you next time. We'll do it in class. Hey, we will have the test on 12-1, 12-2, and there will be a few problems from 12-3, but we'll go over it in class and do a couple of them. It's really easy, actually, okay?